And Alex started to call this out when we were working. Others of you may have picked up on it too. What is it about these numbers that makes it so that some of them work but some of them don't? Like, how could I tell just by looking at the numbers whether I was going to be able to get a triangle out of it? Brooke?
The length?
Okay, what about the length? What do I need to make sure happens?
They're all close to the same size.
Well, like 7, 9, and 3. 3 is kind of far away from 7 and 9. What do you think, Clay?
If they're all even, then or if they're even or odd, it doesn't matter. They have to be.
Okay, well, here I have odd, even, even. These are all good guesses. Here I have even, odd, even.
Yeah,
Alex?
I did the highest, and you do the highest, or the two lowest numbers if they equal or are more than the highest number.
Okay, Mike, what were you going to add to that?
Kind of the same.
Same thing.
Like the base, one of them has to equal at least half or more.
Okay, and actually it's not even that it's half or more, but I like the way you're thinking with that. But the problem you run into, see like this one, like 3 is not half of 7 or 9, it's less than half. But you need the two other sides, the small sides, added together to be bigger than that third side, because otherwise you run into a situation like this one, where the two smaller sides aren't long enough to where they can meet with that big side in between them. Now, Alex said if they're equal to or greater. If they're equal to, like this one, 3 plus 7 was exactly equal to 10. And what you probably found was that you had your 10 down here, and then your 3 and your 7 just kind of laid down flat on top of it, because they're exactly the same length. So actually what we find out is that for 3 sides to be able to make a triangle, you always need every combination of 2 of them to add together to be bigger than the third one. So that's what the triangle inequality theorem says. And I'm going to go ahead and talk about what those mean. So the triangle inequality theorem says the sum, which means when you add together, the sum of any 2 sides always needs to be bigger than whatever the other side is. So here it shows you that I'm adding together all the different combinations of sides. So I'm adding together AB and BC and making sure that's bigger than AC. And I'm adding together AB and AC and making sure that's bigger than BC. I'm checking all the combinations. But really there's only one combination you have to worry about. And Alex said it when he was giving his description. You have to make sure the 2 smallest ones add up to be bigger than the biggest one. So like here, 4 and 7, that adds up to be more than 10. 8 and 8 adds up to be more than 8. But look here, 3 and 4 does not add up to be more than 10. That's why that one doesn't work. Okay, and it's got to be greater than. It can't be exactly equal to. Got to be greater than. Why do I not have to worry about checking the other combinations? I don't know. Like why up here do I only need to check that 4 plus 7 is bigger than 10? I don't need to say, okay, is 10 plus 7 bigger than 4? Keegan?
Because if you do the 2 smaller ones, then you know the biggest one will automatically be higher than the others.
Exactly. That this one is already higher than both of these, right? So if I take this one and add it to one of these 2, of course it's going to be bigger than that third side. So when I hand you a set of 3 numbers and I say, will this work? You don't have to check every combination, even though technically you're supposed to. The only one that might not work is the 2 smallest. You need to check and make sure they're bigger than the biggest. Okay? So 3, 5, and 9, would that work? Why not? That's right. Okay? So for my explanation, I could just say no. because 3 plus 5, which makes 8, is less than 9. Okay. What about 3, 7, and 9? Would that work? Yes, because 3 plus 7 is bigger than 9. Okay, so that's why that would be a yes. I have no idea. Mr. Nelson's getting rowdy over there. I could go through and say, okay, is 3 plus 9 bigger than 7? Sure it is, because 9 is already bigger than 7. And then is 7 plus 9 bigger than 3? Sure it is, because both of those are already bigger than 3. So this is really the only one you need to worry about. Okay? Okay, let's try this question. Oh, sorry. Oh, well I forgot about this example, but okay. Give me the example, or give me a set of 3 numbers that would work. Somebody raise your hand and give me a set of 3 numbers that would work. Clay.
4, 7, or 6, 7.
4, 6, and 7? Is 4 plus 6 bigger than 7? Yep, so that works. All right, somebody give me a set that would not work. Brooke?
10, 3, and 4.
Okay, 10, 3, and 4. Oh, is that our same one from up here? It is. Let's do a different one.
Oh.
That's okay. Give me another set of numbers that would not work. Alexis, you got one? 10, 5, and 4. Yep, because 5 and 4 are not bigger than 10. Okay. You could get really crazy on that one, right? You could do like 1, 1, and 100 too. That one wouldn't work, right? Because the 2 1s would flop down and not be able to make up that distance for the 100. Okay, this is a tricky question. And if we need to do a couple more examples of this type of problem, we will. I don't know why this question is so hard, but it is every year. Okay, so I run into this every year, that this is a confusing question for people. So if I tell you I have a triangle, and 2 of the sides are 15 and 20, I want to know, this question says the third side must be longer than what? That's a complicated way of asking, what's the shortest that third side could be? Anybody know? What's the shortest it could be? Any thoughts, Blake? Where are you getting 15 from? Because that's the shortest one here. Okay. Remember that, okay, so if I have 15 and 20, and I want to know the shortest it could possibly be, it's going to be something smaller than 15. Kennedy?
6.
Okay, where are you getting 6 from?
Because it has to be longer than the longest. I mean, 15 has to equal plus the smallest.
Yep.
1 has to equal more than 20.
Okay, so we need to be able to add this one plus 15 and have it come out bigger than 20. So I see where you're getting 6 because 5 is like my limit, right? So 6 would be the next biggest one. But is there anything that's bigger than 5 that's not 6, Blake?
5 point.
Yeah. Couldn't you have like 5.001? And that'd be a really, really like skinny triangle, but it would still work, right? Because it would still technically be bigger than that 20. So I don't want to say that it has to be 6. I don't want to jump up to that next number. I just want to say it has to be bigger than 5. Okay? So it has to be greater than 5. Clay, question?
Like, how would 35 work? 'Cause
We're going to talk about 35 in a minute. I want to know what the shortest side could possibly be. Okay? So, like, I could have a 6 in here, and 6 plus 15 would be bigger than 20. Or I could have a 12 in here. 12 and 15 is
couldn't it
bigger
go
than
in
20.
different order though, like 15, 20, and then
They could. So, but that's, you're answering a different question. Your answer is actually the answer to our next question. I wanted to know what's the shortest it could possibly be. What's the smallest? Okay? Now I want to know what's the longest it could be. Okay, what it has to be shorter than what? What's my limit for how long it can be? What is it? 35, right? That's what you just answered.
I'm
Okay.
confused.
Okay, I'll go over it again, but back at this one had to be longer than 5. For looking for my shortest side, the smallest I can get, because this is saying it must be longer than, so what's the smallest I can get? Smallest I could get would be anything bigger than 5. I've got to stay above 5. Because anything bigger than 5 is going to combine with 15 to be bigger than 20. Now this question says it must be shorter than that. So I'm looking for my upper limit now. Where did Clay get 35? Luke? Yeah, so now I'm saying, okay, what's the longest it could be? So you're right. Now I'm going to say, what would happen if our side was over here? What if our longest side was up here? Well, the highest it can be is, well, it couldn't be exactly 35, right? But could it be 34.999? Sure. So I just want to say that it has to be shorter than 35. Must be shorter than 35. So it has to be bigger than 5 and shorter than 35. Okay, so that gives me like a range. That means that my side lengths can be anywhere between 5 and 35. And so the last question says, write an inequality to represent that. Now, I'm going to show you how to do this. I know you haven't done a ton with inequalities because we haven't done algebra yet, but I want you to know that every one of your answers is going to look the same way. How did I get that shortest side, by the way? Like, what did we do with the numbers to get 5? Carly? Okay. How would I look at 15 and 20 and get that answer of 5? What did I do with the numbers? I heard it. Gabby? Subtract. Yes. So I subtracted. I did 20 minus 15 to get 5. How did we get the 35? We added. So we did 20 plus 15. Every single one of these questions works that same way. You're going to add them together and you're going to subtract them to get your two numbers. And then to write your inequality, start with your smaller one. So you're going to write a 5 less than x, because you're saying that x needs to be bigger than the 5, and then less than 35. Okay, that's what your inequality looks like. If this part is freaking you out, it's going to look like that every single time. So just remember that you're always going to do less than x, less than something. Okay, smallest number, biggest number, and then put that less than x, less than in the middle. Okay. Let's try another one of those for those of us who are... give me two numbers. 7 and 10? Okay. So if I give you 7 and 10 as two sides of a triangle, what's the smallest that the sides could be? If it's like less than 7, if it's small, what's the smallest it could be? It's got to be above 3, right? So it's got to be like 3 plus. Okay? It can't be exactly 3, but it's got to be above 3. What if my other side was on this side? What's the biggest it could get?
16.99.
Yeah, the biggest it could really get is 17. Well, it couldn't be exactly 17, but you're right. It could be like 16.9 repeating. So this would have to be, this is bad notation, but this would have to be under 16. No, sorry, under 17. Oops. Didn't mean that. Have to be under 17. Remember, you wouldn't want to say 16 because then you're excluding like 16.01 up through 16.99. So to write my inequality, I'm going to start with my smallest. So I'm going to say 3 is less than x is less than 17. And as long as you don't put those equal bars underneath here, you're saying that it can't be exactly equal to 3. It needs to be bigger than 3 and smaller than 17. Okay. One more. Give me 2 more numbers. Let's get crazy. Give me some crazy numbers.
100.
100?
125.
125.
Okay.
That's getting really
Okay.
crazy.
124. Now my numbers are out of order this time, but what is the smallest other side that I could have here? 76. Well, it's got to be above 76, right? Which means that I couldn't actually have anything less than 24, right? 24 must be my smallest side. because there's nothing less than 24 that when I add it together would be greater than 100. So 76, whoops, I didn't mean to equal to, less than x, less than, what's my biggest side going to be?
123.99.
Okay, so that's how you write the inequality. Every time you have one of those problems, that's what you're going to do. Okay? You're going to add the numbers together, you're going to subtract them, and you're going to put that inequality piece in the middle. Got it?
Got it.
Okay. Okay. Number 1 says put the sides in order. Now what I want to draw your attention to, my microphone's freaking out today. What I want to draw your attention to is this says sides. What kind of thing are the sides of a triangle? They're segments, right? How do we name segments? How many letters? Yep. Segments, which means 2 letters. So you're not saying like A, comma, B, comma, C. Okay, there's no such thing as side A. There's an angle A, but there's not a side A. So if I want to list in order from smallest to greatest, here's what I do. I find my smallest angle. Where's my smallest angle? A, the 30, right? And I look for the side that's directly across from that angle. So that'd be BC. So that theorem we were just looking at says that if this is the smallest angle, then this must be the smallest side. Okay? So my first side that I'm going to list is BC. That's my smallest. What would be my next smallest? AB, yep, because this is my next smallest angle, so there's my next smallest side, AB. And then my last one would be across from the 110, that would be side AC.
Does it matter which order you're going in?
The letters, you mean?
Yeah.
No. So like you could have called this CA. Okay, but you do have to make sure that you're naming them in the correct order. Angles and sides, they work the same way. So the next one says put the angles in order. It gives you the side lengths and it wants you to figure out the angles. Okay? So again, if I want the smallest angle, I'm going to look for the smallest side and go directly across from it. That'd be angle B. And this time you can just use one letter because you're talking about angles now. So make sure that you read the question. What things are it that you're putting in order? Angles or sides? So there's angle B. What angle would be next? A, yep, because this is my next biggest. That's across from angle A. And then finally, angle C. Not hard, right? Kind of common sensey, I hope. Okay. This is sort of the next piece of today. I know it's a lot today, but exterior angles. I'll give you a minute to write. I know there's some writing you got to do on this slide. Okay, exterior angles. Go ahead and jot that down. So exterior angles are formed by taking one of the sides of a polygon and extending it and making it a lot longer. Okay? So these angles we've talked a lot about. These are the interior angles. The exterior angle would be this guy out here. Okay? But what's convenient is that that exterior angle forms a linear pair with the interior angle that it's right next to. So like if I highlight this angle, and then highlight that exterior angle. Do you see that together they make a straight line 180 degrees? Does that make sense? Okay, that's going to be helpful to us in a minute, that we can calculate this exterior angles by subtracting from 180 with that interior angle. Okay, are we done writing? Okay, so what do you know about the three angles in a triangle? They equal 180, right? So using this picture, I could say angle 1 plus angle 2 plus angle 3 is equal to 180. Okay, so I know that. This next question is worded kind of funny, but just so you can see what I'm talking about. What do I know about the exterior angle, which is angle 4, and the adjacent interior angle, so the interior angle that's right next to it? What do I know about 3 and 4? They also equal 180. You were about to do a little mini proof. So what I want you to see here is if this is equal to 180 and this is equal to 180, what do I know about this and this? They're equal to each other, right? If they're both equal to 180, they have to be equal to each other. Here, okay, I had 1, 2, and 3 equal to 180. I had 3 and 4 equal to 180. Since they're both equal to 180, that means I can make them equal to each other. So I can say angle 1 plus angle 2 plus angle 3 has to be equal to angle 3 plus angle 4. Does that make sense that those two have to be equal to each other since they're both equal to 180? What property was that, by the way? When two things are equal to the same thing, then they must be equal to each other. Cameron?
Transitive.
That's a transitive property, yep. So the thing that let me do that was the transitive property. Okay. What do you see on both sides here? What do the two sides of the equation have in common? Keegan? Okay, they both have an angle 3. So aren't I allowed to just subtract angle 3 from each side? If it's on both sides, I can cancel it out on both sides. And that leaves me with angle 1 plus angle 2 is equal to angle 4. Okay? And that right there is called the exterior angle theorem for triangles. Okay? That means that if I'm looking for angle 4 out here, I can find it by taking these two angles, the ones that are not right next to it, and adding them together. These two together have to equal that angle 4. That's called the exterior angle theorem. Okay, so we just proved a theorem. Because this up here, we have a theorem that tells us there's 180 degrees in a triangle. We also have a theorem that tells us that a linear pair makes 180. Then we use the transitive property. Then I subtracted from both sides, which is called the subtraction property. And then I concluded with this. That was a proof that you just did. Okay? I'm going to pop up here. This out. Okay. So knowing that, what we just talked about, take a look at this picture. You've got an exterior angle here, and you've got interior angles here and here. So what relationship do I know about these things? How do these three angles relate to each other? Think about that theorem we just talked about. Go ahead, Keegan. What do you think?
7y minus 11 plus 3y plus 1 equals 9y plus 1.
That's right. We just said that these two angles together have to equal that exterior angle. Okay? So, whoops, didn't mean to do that. I'm going to shrink that up so I can write my equation. So 7y minus 11 plus 3 times y plus 1 has to equal 9y plus 1. Okay, and then I'm going to solve. So I'm going to distribute the 3. 7y minus 11 plus 3y plus 3 equals 9y plus 1. Combine the 7 and the 3, so that's going to give me 10y. I'm also going to combine negative 11 and 3, which makes negative 8. So 10y minus 8 equals 9y plus 1. And then what? Brooke?
You add 10 and 9y?
Well, I can't just add them because they're on opposite sides of the wall.
Oh.
So I need to pick one up and move it.
Oh, add 8 to the other side.
Okay, I could do that too. So let's add 8. Add 8. So now I have 10y over here equal to 9y plus 9. Okay, I do need to get those y's together. Brooke was right, I need to get them together, but I can't just add them together. Blake? Subtract how many y? Okay, so subtract 9y, subtract 9y. 10y minus 9y is just going to give me 1y, or just y. So y would equal 9. And I think that problem just said find the value of the variable, so I'm done. If I wanted to, I could make you go back and figure out what all three of those angles actually equal, but I won't.